Welcome to Integrated Math 3 Unit 1 Review Part 3. We're starting at number 21. All right, number 21, this is the equation that I gave you guys in class. It's f of x equals 6x cubed plus 5x squared minus 7x plus 2. And the question one, which shows all possible rational roots of the above polynomial? And so when they ask about all possible rational roots, you should be thinking the rational roots theorem. So the rational roots theorem, to remind you, says that all rational roots of a function, of a polynomial, can be found by looking at the ratio of the factors of the last term to the factors of the first term. So here's my a(n) and here's my a0. Remember, all of my values for p come from a0. So all of the factors of 2, which are plus and minus 1, plus and minus 2. All of my values for q come from my coefficient of my first term, an, which is 6. So plus minus 1, plus minus 2, plus minus 3, and plus minus 6. All right, and then to find those possible rational roots, we make a ratio of each of these p's to q's. So we've got plus minus 1 over 1, plus minus 1 over 2, plus minus 1 over 3, plus minus 1 over 6, plus minus 2 over 1, plus minus 2 over 2, plus minus 2 over 3, and plus minus 2 over 6. Now, sometimes roots are repeating, so you need to check for simplification. And so when I check for all my simplified roots, plus minus 1 over 1 is 1, plus minus 1/2, that cannot simplify, plus minus 1/3, that doesn't simplify, plus minus 1/6, that does not simplify, plus minus 2. 2 over 2 is the same as 1, which we already have, so we don't need to repeat that one. Plus minus 2/3, that has not shown up yet. And then plus minus 2 over 6. 2 over 6 reduces to 1/3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible rational roots. Now, when we look back at the answer choices, the only one with those answer choices would be C. All right, so the correct answer here was C. All right. We're skipping number 22. That was the binomial expansion. We did not do that in regular math 3. All right, number 23. Number 23 says, which of the following, the graph of polynomial function p of x is shown. Which of the following must be a factor of p of x? All right, so we have 3 zeros in this graph. Our 3 zeros are at x equals -3, x equals 0, and this was actually a double root. I know that because it bounces off of the axis. And then again at x equals 2. So our 3 zeros are here at -3, at 0, and at 2. So then the factors that led to these would be, well, I would move the 3 back over. That would be x plus 3. This I wouldn't have to do anything with. I would just have, so that equals 0, right? This I would just have x equals 0. I would have x equals 0. And this I would move the 2 back over. That would be x minus 2 equals 0. So my factors were x minus 3, x, and x minus 2. I'm sorry, x plus 3, right? And those would have been the factors that led to this polynomial. So select all that apply. X was a factor, x plus 3 was a factor, and x minus 2 was a factor. All right, next. It says consider the polynomial functions f of x equals x to the 4th minus 18x squared minus 81 and the graph that's given. Okay. So it says, which of the following statements best compares the intercepts of f of x and g of x? So it says f of x has more x-intercepts than g of x. I don't know. I have to graph it to find out. F of x has fewer x-intercepts than g of x. Again, I'd have to graph it. F of x has the same y-intercept as g of x. Now that I can see in the equation, the y-intercept here is negative 81. The y-intercept here is 60. Definitely that's not true, so we can get rid of c. And then finally it says f of x has a greater y-intercept than, this should say g of x. Again, f of x has a greater y-intercept. That's not true. F of x has a y-intercept of negative 81. G of x has a y-intercept of positive 60. So that's not true either. All right, so now in order to answer this, I'm going to have to sketch a graph of this function. Unfortunately, this function is not factorable. F of x equals x to the fourth minus 18x squared minus 81. If this were a positive 81, I would be able to factor this, but because it's negative 81, there are no two values that I know of that will multiply to negative 81, like negative 9 and positive 9, and then add to 18. That doesn't add to 18, that would add to 0. Now, if I change the signs here, it'll add to negative 18, but it won't multiply to a negative. It'll multiply to a positive. So it is not factorable. All right, so I just have to use what I know about this graph. I know that it will have upward end behavior on both sides because the degree is even, right? The degree is a degree 4, so the degrees or the end behavior will match, and it will have a up end behavior because a, the value of the leading coefficient, is positive. So the graph will be doing something like this. I also know that this graph crosses the y-axis at negative 81. Okay, so now I'm going to give you a sketch and see, is there any way that we could come down, right? Oh, also something else I know really quickly is that this is an even function because all of the degrees are even. So it will have symmetry at the y-axis. So if it comes down on one side, it'll do something similar on the other side. Now it's got to bend somewhere down here in order for it to cross the y-axis. Could you picture if it was bending here, right? It would be crossing the y-axis somewhere here. If it were bending and going back through, right, it would bend up here. So if this y-intercept had been positive or it had been 0, it could be that it bends, goes through, and you could have 1, 2, 3, 4 solutions. However, in this case, in order for it to touch that negative 81, it's got to come down, bend, come back down, and come back up. And these values have to be the same on both sides of the graph. One will be positive and one will be negative. All right, therefore I'm confident that this graph looks something like this. So this graph will have 1, 2 x-intercepts, and this graph has 1, 2, 3 x-intercepts. All right, so A says f of x has more x-intercepts than g of x. This is g of x. G of x has 3. F of x only has 2. And then finally, so that's not true. So finally it must be B, that f of x has fewer y-intercepts, which is true. All right, our very last question says, what are the solutions to the inequality f of x is greater than 0? Graph them on the number line. All right, so we're looking at our graph, and our graph says that we have greater than 0, right? Greater than 0. That means where the graph is positive or above the x-axis. So the values for that would be from negative infinity, right, until negative 2. So from negative infinity up to 2. So for any value, or sorry, not 2, negative 2, excuse me. So for any value x is less than negative 2, right, where x is less than negative 2, the graph will be above the x-axis. So x is less than negative 2, open circle, going to the left, X is less than -2. All right, and then it stays below the x-axis, stays below the x-axis, and then at +4, so from 4 to infinity, the graph is above the x-axis. So that would be for x is greater than 4. So open circle and going to the right forever. And those are our values for which the graph is positive. So greater than 0, right? Not greater than or equal to, so only greater than, and so open circles. All right, guys, that's the entire Math 3 Unit 1 review. Please make sure that you have done your review so that you can ask me any questions tomorrow. Have a great rest of your weekend.